Welcome to the 2022 Winter Classic Student Cluster Competition Studio Update Show. Now, here are your hosts, Dan Olds and Addison Snell.
Hi, everyone, and welcome to the Intersect 360 Research 2022 Winter Classic Invitational Student Cluster Competition Studio Update Show. I'm Addison Snell alongside Dan Olds. Dan, this really gets made possible by the mentors who help the students, and we got a good one in the studio today.
Yes, it does. And you may have heard of these folks before. These are the folks from the Oak Ridge National Laboratory. They put together
leadership computing facility
yes,
at Oak Ridge National Labs.
It doesn't get much bigger in HPC than this. And they put together a challenge that was unprecedented for this competition. It's the first machine learning type of thing we've done. And it threw the students for a loop early on, but they pulled through. Let's go ahead and bring them in. What a great
skill to be learning. So yeah, very grateful to Oak Ridge National Labs. Let's bring in the team.
Let's bring them in. So hello, Oak Ridge team. How are you today? Everybody okay?
Doing good.
Good.
Good. How are you?
Very good.
Hello.
Very good. Would like to just go around and get some basic introductions from you and tell us what you did with the competition. Let's go ahead and start with the queen of the application.
Hi, Antigone.
How are you?
Hi. Good. How are you doing? So let me introduce myself, I guess. I'm Antigone Georgiadou. I'm a computational scientist at OLCF. I'm in the science engineering section. I'm a mathematician by training, and I'm almost heavily, all my time is consumed involved in exascale code development for the Frontier supercomputer that's coming up.
Fantastic.
And I'm interested in doing some multi-physics simulations of explosive stellar phenomena, supernovae.
If you're going to be looking at anything out in the sky, why not explosions, right?
I mean, yes.
It's the most interesting stuff.
And you get to discover many things that, for example, the gold around your neck is produced during these explosions. You don't get to produce that on Earth. So
really, it all came in through comets and meteorites and that sort of thing?
Yes.
Wow.
That comes from the supernovae. That's why we started to see the process that produces these heavy elements, heavier than iron.
Okay.
Gold, nickel.
I did not know that. Addison, did you know that?
Yep.
Okay. Well, score 1 for you. Suzanne, tell us a little bit about yourself.
Hi, I'm Suzanne Peretti-Kuhn. I'm a high-performance computing engineer here at Oak Ridge Leadership Computing Facility. And myself, along with Tom Papa-Theodore, who you're going to talk to next, and a huge team of people from our user support team, we organize the training that teaches students how to use Summit, and maybe a bit more than that. There's a foundational skills for HPC in general. So we were the pre-training crew, and we did a hands-on Summit workshop with the students where they had challenges that they had to solve that were not as big as Antigone's challenge, but little challenges about how to use the machine. And we set up a fun little leaderboard. We had pretty decent participation for those that logged in, and a lot of people did the exercises and I think learned a lot.
Well, Tom, tell us a little bit more about that. I mean, it was a total of what, about 3-4 days of training, recorded training?
So there was an afternoon of pre-recorded training that covered foundational skills like how to use text editors, Unix, how to program in C, how to program in Python, the basics, like an introduction. So that was pre-recorded with sort of like an online workbook in GitHub of exercises.
That's right. That's where they spent the extra time doing the exercises and all of that. That was very, very helpful.
I'm glad they utilized those materials. Yeah.
Did you see a correlation between the teams that did well and the teams that utilized all that?
I think so. Yeah, I think that our leaders from the leaderboard are probably on our leading teams here. So yeah. So those were the foundational skills. But the day that we actually did the training, Tom goes through with them every aspect of what supercomputing is and the programming models. And then they get these high performance computing related challenges that cover, methods of parallelism like MPI and OpenMP and how to use the GPUs, and then some preparatory CUDA things that Michael Sandoval developed for machine learning with Python, just the first steps of how you would start the learning there. So that was the live training that we did, and a lot of them participated that afternoon. It was good,
and quite a few picked up on the recorded sessions as well. So Tom, tell us about you.
I'm Tom Papatheodore. I'm an HPC engineer at the OLCF in the System Acceptance and User Environment Group. So I run some tests that measure the functionality and performance of GPUs on our pre-production systems here. And I also organize the training events for the users who have early access to these pre-production systems.
Okay, so you know your way around Frontier already.
Yep. We've been using the early systems for quite a while now, and so we have some of the actual hardware here and some pre-production systems as well. And so we're all getting well versed in that system.
We've seen that Crusher system is up now. That's got to be exciting. And we're not going to pump you for any more information about Frontier.
I dearly want to.
I've heard of it, and we are interested.
Yes. As folks that measure, the market, we're deeply interested in when that's going to be accepted, but we're not going to ask, right? Right.
Oh.
We're not going to ask. Not saying it, nothing. So before I ask him that, let's move on to Dan Dietz while I can still control myself.
Hi, I'm Dan Dietz. I'm an HPC engineer as well at the OLCF. My first experience in the world of cluster competitions was back in 2010 as a competitor in the supercomputing cluster competitions.
We must have met then.
I think we did.
That was the first time I started interviewing the teams. Who are you with?
Purdue.
Purdue. Okay.
Yeah.
I know I interviewed Purdue. I know we met them.
Yeah.
Very good.
So too. Yeah. So I think that was kind of a key moment in setting my HPC career path in motion.
Really?
So I think these types of events are super useful for aspiring HPC professionals. So I was really excited to be able to help contribute and organize the lab's contributions to the Winter Classic.
And this isn't the only cluster competition you're involved in this year, right? Tell us about the other one.
That's right. I am chairing the Indy SCC at Supercomputing in the fall. It's very similar to the Winter Classic. It's got an education focus. The committee finds the hardware to run on. And you can compare that to the traditional student cluster competition where the teams go out to vendors and fight hardware. And they're a little more on their own, relying on their own institutions' resources to build up their team.
So virtual competition, you're going to go out and find some willing cloud type resource. And students still have time to sign up, right?
That's right. Applications are open until the end of April. So if anyone's interested, go on the supercomputing website. You can find the link to apply.
Very cool. Very cool. And last but not least, Veronica, how are you? Tell us about yourself.
I'm doing good. Thanks for having us today. So my name is Veronica Melissa Vergara, and like Dan, my involvement with the student cluster competition was a while back. It started at Supercomputing 13. I was helping as an application analyst. So the role that Antigone helped with for this competition is what I started at SC doing, and that link actually helped me the network, and my job at Oak Ridge sort of led from that involvement. Wow. It was great to, it's actually sort of like opened a lot of avenues for me. And then it helped me see other parts of the HPC careers that one can have. And actually I know Dan from when we were working at Purdue together. And so it's, there are definitely a lot of like ties. HPC is a small world. But
Dustin Lieberman, right?
Yeah, exactly.
He's still there. Yeah.
The student cluster competition there. when I was the application analyst, and H&M, who was heavily involved with student cluster competition. So since then, I've been trying to help the student cluster competition in many different ways, and the Students at SC program. And actually, SC20, I was co-chairing the student cluster competition for supercomputing with Scott Michael and Indiana University, that I'm sure you also know very well. And that's actually why I'm wearing my SC20 jacket today.
Very nice.
But I highly want to plug the student cluster competition as well, not just the Indy SEC, but the student cluster competition at SC, because it's a great opportunity. As Dan said, it gives the students like a whole spectrum from system administration to how to run jobs to how to process data, which is they're highly sought skills for places like Oak Ridge. So
absolutely.
If you get that experience, make sure you apply and try that.
We're going to have to get you a student cluster competition jacket next.
Oh, there you go.
Yeah. Or the souvenir coffee cup.
I'm all for swag. But yeah, I wanted to also mention, so my role now at the Oak Ridge National Lab is system acceptance and user environment. So my group is preparing the systems. Currently, we have Crusher, the test bed is pre-production. So we come up with tests and try to ensure that things are working correctly. And as a result, I touch different applications and are trying to find like, what are people running today? And how do we make sure they can run those things in their next system? And basically, our job is to find the problem so that users don't have to find them when we put the system into production. So
much better way to go to pre-find those problems. So,
well, speaking of problems that people are running today, you've introduced machine learning now into the student cluster competition. What a topical thing to get the students going on. It's a little bit of a different sort of challenge doing machine learning training as opposed to the traditional deterministic types of scientific applications that we have out there. But you got the Summit supercomputer there as your background. It's a perfect machine learning node. And the students were working on essentially the same nodes that go into Summit. How was that experience?
Yeah, I think that's definitely one of the reasons why we wanted to do machine learning. Even though it's not really traditional workload we've seen in previous competitions, we have seen that people in Summit are using a lot for, like, they're doing a lot of training. They're trying to explore different scientific domains using machine learning. And the usage of that has been growing and growing more. And I think it's a great experience too for the students to get some practice on that field, because it's also a very hot topic. If you're going to industry or other fields, having that experience is super useful.
Can you tell us about the application itself?
Yeah, please.
Dan was referring to you as the queen. What's the application that they were running?
So what I was trying to do with this application was to introduce the students to something that I love, machine learning applied to astronomy data, cosmological data. And they started off by doing some training exercises, meaning that these exercises use data sets that are out there and trying to get themselves familiar with machine learning and how it can be used for dimensionality reduction and everything. Ultimately, the exercise used cosmology data from simulations, and that's the one key that they were able to see changing the neurons, the structure of the machine learning method itself, the neural network itself, how that changes the outcome. So what I wanted for them to see is that there is the intersection between science, HPC, and computational methods like machine learning that can tackle those very hard problems to solve.
And there was also a computational energy efficiency angle to this too, and that you were looking for them to find what?
I was looking for them to, so you can around this, there's no right answer. From the beginning, you don't know a priori how many loops, how many times you will run that neural network. So I wanted them to see what's the fine line, what's that sweet spot that you should start the training and testing your machine learning method and gives you the best result. That's what I wanted them to see. Also, with the PCA method that they worked a lot with, how So the PCA method captures all the underlying, the most dominant modes of the data. So what's the most you can get from the data with the most efficient way? And that's something that we need to work in the future, and scientists work for efficiency in data, in computational power, for all of this.
Very, very good. On the training side, I'm talking about training the students, not the model. I was a little worried there. It seemed a little rocky at first, but then it also seemed to come together. What were your views of it? You know, Tom and Suzanne, Dan, because you were monitoring those Slack channels.
So certainly go ahead, Tom.
Well, I was just going to say that, the participation that Suzanne and I were mostly focused on was the introduction to the supercomputer itself, right? The hands-on with Summit. And so for that, I don't think that was maybe rocky. Maybe you're talking about the actual machine learning application. But I think that with the hands-on with Summit, I think that it was something that we did to introduce the students to the system. I mean, it is used for what Suzanne mentioned, right? Which is to introduce you to HPC topics in the context of Summit. But for these students, since they already had some HPC background, it was more of an introduction on how to use the system, using the job launcher, that sort of thing. And I think that went, fairly smoothly. And the students enjoyed that part. I can maybe let Dan, Veronica, or Antigone speak to the rockiness of the machine learning side of it.
Yeah. What do you think? Go ahead, Dan.
Yeah, I was going to say, with it being kind of a new thing for the students, I was a little worried that it might be a lot for them, but I think everything came together pretty well after the teams had some chance to work through the exercises and understand them. It seemed like the students understood overall pretty well what we were asking of them.
Very good. Anybody else have anything to add on that?
Well, I was getting, so the first couple of days, I got some questions that were either too good, like they're they're doing good progress, starting off with a good foot. But then I was seeing some difficulty in actually starting the project. And I felt like, I don't know how many students watched the presentation that we did, the training. That will be one thing. And I'm not sure that they were able to actually read the whole instructions. I'm not sure for the future, maybe something that it's more clear to them on where to start. But the application itself was unique. So I can see why it intimidated them at first.
It was not something they could Google up and figure out.
Not really. But the messages that I was getting, maybe Monday, Tuesday, they were started to warming up. It was, that's what I sent out to the rest of the team, that I'm getting messages that ask really good questions. So I'm not really worried at this point. So, and at the end, so many teams did excellent. Perfect.
Yes. And let's talk about that for a second. We had 4 teams that had perfect scores on this. We had 3 teams that didn't manage to submit anything, but that's pretty good for any student cluster competition.
Now, we've seen that before. Sometimes it's just a little more than a team was ready for in the week, but 4 teams with perfect scores, that's what I like to look at there.
And then a 5th team that was, half a point under a perfect score, or 5% under a perfect score. That's pretty good.
And 12 teams learning about machine learning.
That's even better. Yes. And we've talked to a few of the teams since your challenge ended, and it was an eye-opener for all of them. And there are some students that are now kind of intrigued with machine learning too. So you've definitely done your job. It's definitely worked. Yeah,
and the application wasn't really the ultimate goal wasn't really to optimize allocation on the machine, although there was a part of it that had this. And myself, I wasn't oriented for the questions to go that way, because I was worried that a machine learning process wouldn't benefit from that such power that our machines have. And I think that it was a learning process for ourselves to actually next time we can do more in using more power from the machines, from the systems for these types of applications.
That would be great. Well, I guess that's a leading question. Can we hopefully count on you next year? Or can we at least propose it to you next year? Or was this too traumatic? Because you guys seem to handle this really well.
I think we'll love to support it. I mean, we're obviously, you heard many of us already do student cluster competitions. So if you need us, give us a call.
Well, rather than try to sell you on next year, I will express my gratitude for you doing it this year. This is absolutely huge for these students. What a great experience.
Yes.
Getting to use these nodes from the Summit nodes and on machine learning. I think it's just such a tremendous experience. And I'm grateful for your mentorship and participation.
Absolutely. Thank you so much. We really appreciate it. The students appreciate it. And who knows, you might see some of these students walking the halls at Oak Ridge.
Suzanne.
So I want to point out an opportunity that is very machine learning based that's coming up. April 11th, we'll launch the Smoky Mountain Computational Sciences and Computer Engineering Data Challenge. It will have 8 problems. Most of them are solvable with machine learning, but some of them are solvable with traditional HPC. They're all designed to have a variety of questions. The first question is something a student can solve with Python on their laptop, and then the questions get harder. Some of them will have an allocation on Summit to tackle the questions. The students have to be done by the first week in July, and the prize isn't exactly a prize, but they're going to get to publish the ones that have progress towards the solutions. So they'll have a nice paper for the resume. So that's smc-datachallenge.ornl.gov. And all of these 8 data sets are pulled either from eminent data sets at Oak Ridge National Laboratory or our close collaborators in industry and some of the other labs. So challenges would be things like hundreds of images of plants and their tags, and a machine learning thing to read the numbers on the tags out and print it on a spreadsheet. One of them is wind flow, trying to figure out how to make more efficient windmills. And a couple of them have to do with computing, like analyzing how Summit works and how people are using the login nodes. So Hong Lu is the chair for that. It's smc-datachallenge.ornl.gov. And we really hope the students will use what they learned in this competition and go forward and maybe get a publication out of that and get to present a poster in August at the Smoky Mountain Computational Sciences and Engineering Conference.
That's
Publishing
fantastic.
a paper and a poster sounds like a prize to me. That gets your career going fast.
Oh, absolutely. Fantastic. Well, thank you for your time in the competition. Thank you for your time just now. We really appreciate it. Be sure everybody out there and check out the other competitions that we mentioned that Oak Ridge is participating in. And we will talk to you soon. Thanks again. Bye-bye.
Thanks, everybody.
Thank you.
Thank you all.
Thank you.